Hi everybody and welcome to another part of the Solidity tutorials. In this part we're going to see how we can convert the prices from Ethereum to dollar or any other kind of coins or tokens to dollar. So this smart contract is really important because, as you can remember from the previous smart contracts, the bonding curve that Sol smart contracts, the last one of which was the integral, we used to calculate the prices in Ethereum. It would calculate the ETH amount rather than the dollar amount or any other stable coin amount or fiat coin. So in order to make this happen, we need to have a kind of a data from somewhere that is online and it changes according to the prices right now. So in these circumstances, most of the time in the ordinary programming, we say that we use, for example, a kind of an API, that determines the price of the specific coin or token at that specific moment. For example, the Ethereum price at this moment is $1,900, right? But using the API is related to the centralized world. So, for example, we use CoinMarketCap in order to see what is the price of, for example, Bitcoin or Ethereum. But what if we want it to be decentralized to gain more trust and make this decentralized as well? So when we say we want the price to be the price retrieval to be decentralized, we're talking about oracles. So what is Oracle? Oracle is a kind of a decentralized API. So not necessarily API, but it could be anything else. But here what we're going to focus is a kind of an API that is decentralized. Meaning what? Meaning that we get the data from different sources, and these different sources are decentralized. They're not related to one specific place where it gets the data from. So if you want to use a kind of an oracle that is famous, Chainlink is the best option here. So if I just head over to the Chainlink website on data.chain.link, for example, here for the Ethereum price, you can see the exact price right now over here. But you might wonder that what is the difference between what is the difference between this one and the APIs? Well, the actual difference is that this one is more reliable than the APIs that we have all over the internet. So those data are also reliable, but here, because we have a lot of sources that determine our price right over here, this is much more trusted and reliable, and we can use it instead of our smart contracts with more trust rather than the APIs that we have. So every API is centralized, so meaning that one authority determines the price. So what if that authority change their opinion and want to have a different price for a specific coin or token, which doesn't happen often, but what if one day that happens? So having this oracle and decentralized pricing system will help us have more trust over our smart contract. So in this tutorial, we're going to see how we can have this kind of pricing system inside of our smart contract, and how we can have this kind of conversion between the prices using the oracles such as Chainlink. So first of all, we have this GitHub repository for aggregator v3 interface.sol. We're going to use this, but notice that we cannot use this on Remix. I will explain later how to simulate this kind of aggregator v3 interface. But if you're working on mainnet or testnet, you can use this aggregator v3 interface, and then we need also a kind of an kind of a contract address in order to get the price of the Ethereum relative to dollar. So for example, here we have Ethereum mainnet, Sepolia testnet, and Goerli testnet. These two testnets are the most recent testnets. Notice that we used to have Ringp and Ropsten and also Coven testnets, but those testnets are deprecated, and we have Sepolio and Goerli available right now that we can use, but we're going to cover the working with the testnet and mainnet in the future tutorials. But right now we're just on Remix, so we have to create the kind of contract that simulates the price retrieval here in our contract. But later we're going to use these contract addresses in order to use them with this interface of Chainlink contracts and then be able to convert the prices. So right now you might be confused a little bit, but notice that the general idea of using oracles is to have a more reliable system for price conversion. And that's exactly what we need, because sometimes calculating the ETH amount will not suffice. Sometimes we want to set the prices, sell and buy the tokens according to the prices of dollar instead of Ethereum. So in order to do so, we need a price conversion, and as a result, we need the oracle of Chainlink or any other oracles. But Chainlink is the most famous one, so I highly recommend that you use the Chainlink oracle. So with that said, let's get started with the smart contract that we're going to write in this video. Now the first step is to create a new file in the contracts folder. I'm gonna call this price conversion.sol. So or you can say price converter.sol, doesn't matter. So we're gonna copy and paste the first two lines, the license and the version of Solidity. And then we need to import the interface from this link here, Chainlink contract, here the aggregator v3 interface. So the way to do so is to get this address, Chainlink contracts src. So you should also check the version of Solidity, because here this Solidity version is 0.6. Here we have 0.8 interfaces and aggregator v3 interface.sol. So let me copy and paste this one, and so first of all import, and then we have double quote, and then add, and I'm gonna paste the address, but make sure you customize the version of Solidity here. So let me check if everything's okay. So aggregator v3 interface.sol. Okay, so we've got this fine, and let's start our contract. So contract here, because we want to convert the price from VEI to dollar. So as you know, VEI is a smaller unit relative to Ethereum. So each VEI is 10 to the power of 18. Actually, every 10 to the power of 18 VEIs will be 1 Ethereum. So it's a much smaller unit, and most of the time when we enter an amount, we enter it in the VEI. So here I'm gonna name this VEI to dollar. Also notice that we have GigaVEI and Fini. So each GigaVEI is 10 to the power of 9 VEI. So and each Ether is 10 to the power of 9 GigaVEI or GUVEI. And notice that each Ether is 1,000 Fini. So we use these units because our scales are different. Sometimes we're working on very small numbers, and sometimes we're working on the huge numbers, right? Large numbers. So anyway, we have VEI to dollar converter, and so let's open the bracket. So we have aggregator v3 interface, public price fit. So we're using the interface that we've just imported, and now let's make our constructor, and inside of our constructor we will need the address of the price feed. So this is just the same address that I mentioned earlier that you need to copy from the website of Chainlink for every specific token. So public, actually address price feed, and so price feed here. So open the brackets, and we'll have the price feed equals to price feed equals to aggregator v3 interface, and it will get the price feed from there. Here we go. So semicolon, and that's it. So at the beginning of deploying the contract, you will need to enter the price feed for, according to the testnet or mainnet that you're working on, and also according to the price of which token or coin that you want to enter, right? So here you enter the price feed. This is the address that you get from here, but notice that here we're not on mainnet nor on testnet, so we will change this interface right over here. So we will write the interface by ourselves, but right now if you want to see how the contract works on mainnet or testnets, I'm writing it this way because this is the main way it works. But right now, because we're just working on Remix, I'm gonna change this, but later we're going to use this Chainlink aggregator v3 interface.sol, and this will be much easier for us. So anyway, to continue with this contract, we need to first of all define a function. So the function convert way to dollar, function convert way to dollar, way to dollar, and we'll have uint 256 amount in way, so here we go, amount in way, public view returns uint 256, public view returns uint 256, and so open the brackets, and here in the brackets we'll have, so there are a number of variables inside of our parentheses, but we only need one of them, and that is the price. So for the ones that we do not need, we just write the comma and nothing before the comma, and then we'll have int 256 price. Notice that this is not uint, this is int, because for some reason it might be negative, but that doesn't happen very often. So for the other variables, we have 3 other commas, and that's it. So there are 5 variables, 1, 2, 3, 4, 5, yes. There are 5 variables, and so we have 4 commas, but we only need the int 256 price. So then we'll write price. So let me show you what we have right over here. I'm gonna show you right over here. So as you can see, there are a number of variables. The second one is the answer, and that is the price. We have the round ID, we have a started at, updated at. These are the times that it started, it updated, and it answered in round. So we round the number, the price, right? But we only need the answer here. So now let's get back to our contracts. So price feed dot latest round data, price feed dot latest round data, and so we can open the parentheses, and we've got semicolon. So we've got uint 256 ETH price. So we're going to see what is the ETH price in dollars. So uint 256 256 price, and then what we're going to have is the amount in dollar. So the amount in dollar will be calculated according to the price of the vase. So if we get the ETH price, but notice that we enter the amount in vase, so we need to have that conversion as well, meaning that we need to divide it by 10 to the power of 18. So I'm gonna show you how it's going to be done. So uint 256 amount in dollar, so equals the amount in VEI. So this is the amount that you enter in VEI, and so it's going to be multiplied by the ETH price that we've got, and it's going to be divided by, so this is how we write the scientific numbers in Solidity, and you might wonder how it works. How is it 10 to the power 18? But this is how it's written. So this is for, this actually determines the decimals, right? So we're going to, if there's any problem with this 1 to the power of 18, 10 to the power 18, then I will fix this. But I guess this is the right way. But if there's any problem, I will fix this. Don't worry. So we'll have return amount in dollar, so that's how we will return the price that we're looking for. So that's it. Okay, that's it for this contract. This contract will be a price converter, but right now we need to change this to something else. I'm gonna save it for now, and I'm going to also compile it, but we cannot use it because we're not on the mainnet or testnet, right? So let me see something. Okay, we have no semicolon here. Now it's been compiled successfully. And here you need to enter the address of the price feed from somewhere around here in this website. But notice that we are on Remix ID, but if we enter that, we will face an error. However, we'll be able to deploy it, but we cannot see the prices. So in the next video, I'm going to write another smart contract that is going to be replaced by this. And instead of this interface, we're going to write an interface by ourselves, which is the simulation of the chain link contract interface, and then we'll make that happen. So anyway, I will continue with the rest of the tutorial in the next video, and we're going to see how it's going to work. So that's it for this video.